space network. A microwave link relays the messages from space to JPL, the Jet Propulsion Laboratory in Pasadena. This is the nerve center of planetary research.
In a way, it's a bit like a cosmic telephone exchange. The signals are processed here and are sent out to its subscribers, the planetary scientists, and they, in their turn, can use JPL to call up their probes and check up on how they're getting on out there in space.
Information from the probes is fed to the U.S. Geological Survey in Arizona. Here, planetary geologists study the surfaces of other worlds. But first, they need a map. A huge number-crunching computer turns the signals back into pictures and prints out a reference grid to show where they sit. And with some human help, a complete picture of another planet starts to emerge.
It's rather like Christmas during a mission. You're unwrapping a world for the first time. You're dealing with seeing an alien surface that no one's seen before. Right now I'm putting a mantle or a flow pattern around a crater here. It looks as if it's...
Jay Inge has the job of smoothing out and improving the computer's jigsaw. What he makes are the most meticulous artist's impressions in the world.
Of the crater. Bring it up a bit more. But the point to remember is we're making a photo interpretation. We're not making a photograph. The interpretation I make will be looked at by other scientists. It will be corrected for errors. It will go out and other people will throw darts at it and make other little comments of usually a friendly nature. Sometimes the comments aren't too friendly, but we have a very good working relationship with the scientists, and we attempt to do what we can to make the product look as best representative of the surface as we can. Let's bring our little crack in here that appears in the photographs. The rill breaking through here right now seems to indicate that nature can do more than make round circles called craters, and that's important to us, at least to my sanity. I get tired of drawing nothing but craters all day. The fun of it, though, I can't begin to communicate that. I never dreamt I would do this. I never dreamed that I would have a chance to actually be working on making maps of other worlds when I was a mere teenager, looking at it into a telescope. That's good fun. So, onward with the rill and the crack. It does get boring at times, believe me.
This is the end result, a globe of Mercury covered in craters. Thanks to Mariner 10 and a lot of hard work, all is revealed. Mercury turns out to look very much like the Moon. Is there any way one can spot the difference?
Yes, to a real expert. He can look at the craters in one picture and tell the lunar craters from the Mercury craters. Mercury is almost twice as dense as the Moon, so the material that's thrown out doesn't fly nearly as far. And a real expert can recognize this just like he would his own children.
The craters on Mercury were produced by bombardment when it was young. At that time, the solar system was a dangerous place. Asteroids left over from the birth of the planets were whizzing everywhere. Where they hit, colossal stars were left on the planet's still molten surface. Today, every part of Mercury's surface is covered in craters. The huge old scars have been peppered with smaller craters caused by later impacts. But it wasn't just Mercury that suffered space bombardment. There are craters on all the planets.
And here, at Meteor Crater, Arizona, is an enormous hole nearly a mile across, punched into the ground by a huge meteorite which fell about 50,000 years ago. Most of the craters on the Earth have been obliterated by winds or by rain. But on airless Mercury, the craters last forever.
There's more to Mercury than craters alone. Crossing the surface, regardless of terrain, are long, curved scarps, something quite unique in the solar system.
Well, there are fractures where the crust has been broken and ridden over each other. It's the only planet that we've seen where this process seems to be taking place. We think it had to do with so-called core formation. When the dense material melted and fell into the center, then we think the outer crust shrank a little.
It seems the shrinking surface produced the scarps, which can still be seen in Mariner's photographs. Those old textbooks had it all wrong. Mercury isn't half-baked, half-frozen, and it hasn't got a protective atmosphere. It's just a dead, hot, airless little world whose wrinkles are already showing. Far more glamorous is the next planet out from the sun. Shining brightest of all the stars and planets is Venus. She's been an inspiration to romance down the ages. Our fair-haired angel of the evening, now, whilst the sun rests on the mountains, light thy bright torch of love.
Good evening.
Hello. Venus is a planet of romance. Back in the mists of time, people named it after the goddess of love because Venus is quite literally dazzling. No other planet shines as brilliantly. And that's because Venus, true to form I suppose, hides itself under a thick mantle of highly reflective clouds. But Venus is also the closest planet to the Earth, and the combination makes Venus into a world of tantalizing mystery.
Through a telescope, Venus looks like a misty moon. Even under the penetrating scrutiny of a space probe, Venus remains modestly veiled beneath her covering of clouds. Four centuries ago, Galileo became the first person to study Venus with a telescope. He lived in Florence, and I visited the church where he's buried with historian Carol Stott. Galileo spent many years studying Venus, but with his primitive instrument, he the all-enveloping clouds.
Yes, yeah. And after Galileo, other astronomers tried to develop the telescope to actually look at Venus and see if they could really find out the structure of the planet, the surface of it. But it was to no avail, and they really had to just resort to speculation. The most far-fetched idea was from a German aristocrat who actually thought the planet was inhabited, and underneath the cloud coverage were inhabitants who were actually having bonfires, and those bonfires are what we can occasionally see as light patches on Venus from the Earth. One other idea was like an early model of the Earth, so it would be still warm, it would be wet and dripping, and have forests and vegetation, very luxuriant. You could take that a stage further. Other people actually thought that it was completely covered in water and so in one big ocean.
Altogether, it was thought to be a very pleasant place, perhaps a twin sister to the Earth. After all, they are very nearly the same size. And being slightly closer to the Sun, Venus might be pleasantly warmer, a veritable paradise. So, it was with hopeful anticipation that the Russians launched the first ever Venus probe, Venera 1, in 1961. Built Built like a diving bell, Venera was targeted towards Venus's dense atmosphere. In the event, it missed the planet altogether. The Russians shot probe after probe towards Venus, but they all went the same way. As they disappeared under Venus's mantle of cloud, their transmissions mysteriously stopped. It was back to the drawing board. The Russians began to suspect that Venus was rather inhospitable, and they started to build probes that could land on the surface and withstand anything the planet could throw at them. Pressures of 100 atmospheres, temperatures of 600 degrees Celsius. Nothing was left to chance. Even the cameras were made to be virtually indestructible. The color balance was tested in a film studio on a set designer's idea of the planet's surface. These latest Veneras would drill into the surface to take rock samples. They could analyze them by remote control in a mini laboratory on board, bombarding the samples with radiation to reveal their composition. Finally, in Russia's equivalent of mission control, everyone waited for news as the spacecraft descended through Venus's thick atmosphere.
Data have begun coming in. They're of good quality. New information has been received. The presence of neon has been registered in the Venusian atmosphere. No thunder discharges so far, but the instrument called Groza is working. Attention. According to the telemetry, the Venera 13 lander has touched down on the surface of Venus.
The years of testing paid off. Venera's armor-plated cameras sent back clear color pictures for an hour before succumbing to the harsh conditions it revealed. A sister craft landed 600 miles away and photographed an equally desolate scene, a flat expanse of rock glowing with heat. The real Venus is less like paradise, more like hell. Even the volcanic landscape on Earth bears little comparison to the surface of Venus. The Veneras have shown that it's searingly hot, with a dense atmosphere of choking carbon dioxide and sulfuric acid rain dripping from the clouds. A spacefarer setting foot on the planet would be simultaneously roasted, squashed, corroded, and suffocated.
There's no doubt that Venus is the most hostile and unfriendly planet in the whole solar system, quite unlike our luxuriant Earth here. But how come the two planets develop so differently?
On Earth, the sun's heat passes through the atmosphere and warms the surface of our planet. Most of the heat is radiated back into space, so we stay at an even temperature. Long ago, Venus was probably cool enough to have seas, but its atmosphere contained more carbon dioxide, which trapped most of the heat like the panes of glass in a greenhouse. And so, as time went by, Venus's temperature rose, and its seas eventually boiled away. Today, Venus is a red-hot world. These swirling clouds cover the hottest world in the whole solar system. And now, at last, American scientists have found a way of seeing through these clouds. Hal Mazersky proudly presents a new view of the planet.
We have essentially a global map of Venus, or 93% of it. That was done by the Pioneer Venus spacecraft that went into orbit in December of 1978 and is still alive and well.
So how did you manage to see through the clouds?
We used radar. That's really a radar altimeter. You fire a burst of energy at the surface and it bounces back and you measure the time. And that tells you the elevation of the surface.
Under radar scrutiny, Venus is naked, her contours visible for all to see. From the hundreds of radar soundings it made, Pioneer Venus was able to build up a global map of its mountains, valleys, and plains. Here, the highlands and lowlands are color-coded. highlands are green and yellow, while lowlands are picked out in blue. Most of Venus is covered with a huge planet-wide plain. Only the polar caps were left unprobed by Pioneer's radar. Our maps of Venus are growing more detailed. The new features, like the old, are named after famous women. An honourable exception is James Clerk Maxwell, a physicist whose name has been given to an enormous mountain.
Venus is very effective at making mountains and highlands. The highest mountain on Venus is Maxwell Montes, and it's 1,000 meters, 3,000 feet higher than Mount Everest. And it's sitting next to this high plateau, which is 1,000 meters higher and twice as big as the Tibetan Plateau, the biggest one on Earth. And there are lowlands that are about a third as abundant as the lowlands on the Earth, and they're only 1/5 as deep. The processes that make highlands on Venus are more effective than those on the Earth, and the ones that make lowlands are less effective. When we first saw the global configuration of Venus, we looked for the features that are characteristic of the moving plates on the Earth's surface. The most characteristic thing on the Earth is that we have great ridges that run down the centers of the great ocean basins. We don't see those on Venus. Another thing, there are great lines of volcanoes along the edges of the continents. Those are not there. A final thing, there are deep trenches along the coast of North America and South America, and those are not there. So the most characteristic features of plate tectonic motions we don't see on Venus. See, the Earth gets rid of its heat by seafloor spreading and plate tectonics. That's the great grand synthesizing idea and tells us how the Earth was made. But Venus has to do things differently. It has great fractures, some of which go a third of the way around the planet, and lines of volcanoes along these great fractures. And we think it gets rid of most of its heat by conduction into the atmosphere.
But are the volcanoes on Venus still active? Radio telescopes on Earth suggest that they are. A radio picture of Venus is mottled with hot spots, possibly volcanic eruptions. If there are active volcanoes on Venus, they're making a bad planet even worse. The carbon dioxide belching out into the atmosphere will be adding to the greenhouse effect and trapping more of the sun's heat. Venus might have been another Earth, but it went wrong. Just being that bit nearer the sun, losing its seas and having a slightly different atmosphere made all the difference between heaven and hell.
But in a way, we can learn from Venus's fate, because at the moment we're starting to burn the fossil fuels that were laid down millions of years ago, the dead remains of trees. And as a result, the carbon dioxide amounts in our atmosphere are increasing. And there are indications that over the next century, the Earth's temperature could rise by a whole 5 or even 10 degrees. And with it, the trees would go, and we might end up like Venus. So the message is we need to be careful with our own planet, otherwise we too might end up like that beautiful evening star in the sky. Beneath its swirling clouds, the third planet from the Sun is a world of remarkable diversity. But how well do we really know it?
covered in a liquid which has changed its course of evolution. This planet also has life, and in such astonishing variety. We take life for granted, but why is it here? And as far as we know, only here. Jeremy Cherfis is a zoologist who is still searching for the answer. So Jeremy, as a zoologist, how did all this life get started?
Well, it all really depends on the Earth being just right, just the right distance from the sun, so that water stays as water, it doesn't freeze into ice, it doesn't boil into steam. Once you've got water, all kinds of chemical reactions can go on there. We get what we call a primordial soup, and out of that, the first life began. We don't know exactly how.
Somehow, though, life did evolve. Not life as we know it today, but primitive things like bacteria, the forerunners of plants and animals. And as it did, it changed the world, mostly by changing the atmosphere.
In the early days, there was probably far more carbon dioxide than we've got at the moment, and much less oxygen. In fact, there was probably no oxygen. But the plants converted carbon dioxide into oxygen. Then the animals were able to evolve, able to breathe the oxygen on which we now depend. It's a funny thing, but the plants made it possible for us to live, and now, of course, we eat them.
So animals and plants depend on each other for their existence. But neither could survive without one vital ingredient. Our water-laden atmosphere also helps shape the blue planet, our planet. Rivers, oceans and streams are constantly eating away at its surface.
The Grand Canyon has to be the most mind-boggling example of the power of erosion anywhere. It's amazing to think that only 6 million years ago, the Colorado River was a tiny stream flowing across the flat Arizona desert. And since then, it's cut down through these soft sandstones to create this, the most colossal canyon system anywhere in the world.
At the same time, the Earth is continually rebuilding itself. New mountains are spewed out of its belly. Our dynamic living planet is in a state of constant change. The face of the planet is changing on a global scale. Victorian geologists noticed that the continents fitted together like a giant jigsaw puzzle. They thought that millions of years ago, the continents must have started floating freely across the surface of the globe. But they couldn't explain how giant land masses could float, divide, and even collide, forcing up enormous mountain ranges where they did. Continents in collision. It seems absolutely absurd. But it's not. And thanks to the work of Drummond Matthews and his colleagues here at the University of Cambridge, we now know that the continents actually drift around the surface of our planet. Drummond, how did you prove the Victorian geologists were right?
Well, in 1961, I was working across the Indian Ocean, which we didn't know half as well as we do on this map at that time, and I was measuring the magnetic field of the Earth. That's the field which makes the compass point north at the present time. And we already knew in this slab that the field was liable to reverse, that the field coming from the middle of the Earth was liable to change its direction rather suddenly, so that the compass would point south instead of north. And we did some work here in the Indian Ocean. I had a very brilliant research student, Fred Vine, who was here, and we interpreted this story as if the ocean crust was moving away from the crest of the Carlsberg Ridge, which is this bit which we've discovered. The crust was being magnetized just like a tape recording is magnetized, alternately normally and reversely magnetized.
Either side of the mid-ocean ridges, Drummond found parallel strips of seafloor bearing alternating magnetic imprints. Here was the vital clue. The strips were formed during different geological periods and magnetized according to the direction of the Earth's changing magnetic field at the time. But where did the strips come from? Drummond realized the ocean ridges themselves were constantly oozing molten rock. The rock becomes new seafloor, slowly making the oceans wider and pushing the continents apart. Usually, the oceans widen silently, but fireworks blaze when undersea volcanoes erupt, rapidly building up temporary and sometimes permanent islands along the ocean ridges. It's here that the Earth is cracking up. These huge cracks divide the world's surface into a moving mosaic of enormous plates, each measuring thousands of miles across. The jigsaw pieces are larger than we thought. Thanks to Drummond's research, we found the continents actually travel the world on huge slabs, plates floating on the molten rock below. And they're all moving in different directions. It's called plate tectonics. When plates collide, something's got to give. Mexico City, autumn 1985. Thousands of people are dead and millions more are homeless as a result of a slight brush between the North American plate and the small Cocos plate. We might be able to avoid such tragedies if we knew exactly how the plates moved. What is it that drives them?
Well, I think the proper answer is that we don't know. The theory of plate tectonics is a theory which tells us how the plates move at the surface. It doesn't tell us why they move, but we do have hunches, rather more than hunches, properly tested and modelled hunches on the computer, and we think it's probably like the skin on the top of a pot of boiling porridge being moved around by the convection of the hot fluid rising.
So how long has plate tectonics been going on then?
Well, we don't actually know that either, but it's certainly been going on for the last 500 million years, and it's almost certainly been going on for a great deal longer than that. We don't know whether it was the original way that the Earth deformed when it started 3,000 million years ago or so.
Millions of years from now, the moving plates will have carried the continents to new locations. Flying the Atlantic will take longer, but if your aunt in Australia is still alive in 50 million years' time, the good news is that she'll be 2,000 miles further north. There are some changes the Earth has no control over. One is the ebb and flow of the seas, governed from 250,000 miles away by Earth's companion, the Moon. The Moon isn't a planet in its own right because it circles the Earth and not the Sun. But it's an important world, nearly 1/3 the size of our own planet. And it's a mere hop across space, something that has always tantalized mankind. Filmmakers started planning the giant leap long before it became possible.
Roger, Tranquility. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. It's one small step for man, one giant leap for mankind. You're looking good at 2. Ping, Zax, and Misfin all agree.
Some way, when those two Americans stepped on the moon, the people of this world were brought closer together.
It was the most exciting evening. I can remember sitting in a sitting room of a friend, a postgraduate friend at college. And here was something I dreamed of, really, since I read my first science fiction book, actually, which was when I was about 10.
Something fantastic, I think. It was the sort of thing that one always imagined might actually happen, but never believed it would.
Did you watch it on television?
Yes, I watched it on television, yes. I think like most of the rest of the world.
We all left our jobs and went into the the president's room. He had a television set, and we were watching it, and we just found it quite difficult to believe that this had actually taken place.
America's trip to the moon revealed it to the world in a new light. No longer could anyone imagine it was made of green cheese or romanticize over the man in the moon. The moon myths and mysteries we grew up on are now just relegated to library shelves, gathering dust.
You know, for centuries, people have been fascinated with the face of the moon. They've imagined all sorts of things there.
Historian Enid Lake in the library of the Royal Greenwich Observatory.
But I suppose the one that most people saw, and this is a batch of drawings that ordinary people have done, and the one that most people seem to see is the man in the moon, which is the one we're most familiar with.
He doesn't look very happy in those pictures.
Well, no. Many people thought that the man in the moon was Cain.
Who was banished?
Who was banished because he was the first murderer.
Oh, I see.
Some people saw a lady.
Now, she looks incredible. She's real French Renaissance with her hair in curls and that lovely Gallic nose, right? You can see anything, can't you?
You can see anything that you want to. But one animal that was particularly associated with the moon was the hare.
There he is.
Right. The moon was a very benevolent goddess, and she wanted to send a symbol, a sign to man that there was hope for mankind. And the message was that as she, the moon, could wax and wane and rise again, so mankind would rise and fall, but rise again. But we don't know whether the hare was malicious or forgetful, because that wasn't the message that he delivered. The message he delivered was that as the moon waxed and waned and died away, so would mankind.
Oh, no.
And the moon was so angry that she picked up a hammer, she hit the hare, and split his lip. And the hare retaliated, and he scratched her face. And that's why the moon's face is marked right to this day.
I don't know your mind of this.
There it is.
The first astronomers to turn telescopes to the moon were almost as romantic. They saw the dark patches as seas, and only later realized they were dry, desolate plains. They went on to chart the moon as thoroughly as our own world. With the coming of the space age, it was the obvious place to go. January 1959, and Russia's Luna 1, in a gallant display of fireworks, just manages to make it off the launch pad bound for the moon. It misses by 4,000 miles. But 8 months later, with Luna 2, the Russians score a direct hit, and this cosmic football becomes the first man-made object on another world. Before the world can get its breath back, they're at it again with Luna 3. Just weeks later, it nips behind the moon and pulls off the biggest scoop of all, pictures of the moon's hidden far side. The Russians are well on the way to making the moon their own. But would America let them get away with that? If the Russians could send space probes to the moon, then Uncle Sam could go one better.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
And so America blasted off into space. It wasn't long before they too were hurling spacecraft and billions of dollars in the direction of the moon. Meanwhile, a hand-picked bunch of ace American test pilots started training as geologists. One of them might be the first man to set foot on the moon. Once you get there, you've got to have something to do, and you've got to know what you're looking for.
Artemis, on the other hand, has some definite phenocrysts throughout.
We made very capable geologists out of all of them. I don't think normal graduate students in geology get anything like as good training as the astronauts got. And they're very, very clever and very motivated people, so they learn very quickly. We went on a trip to Iceland, and they interpreted a very complicated area in Iceland, and we were there with the guy that had investigated it for many years. They came up with a different answer. They were right, and he was wrong. That gave me some confidence in the fact that they could do the job well on the moon.
The astronauts rehearsed their every move, and America steadily grew more confident it would get there first. But the Russians soon showed who was boss. Luna 9 was a breakthrough. It soft-landed on the moon and sent back the first ever pictures from the rock-strewn surface. Days later, the first lunar orbiter beamed back the anthem of the Communist Party from 250,000 miles away. Russia was almost there, but not quite. It was an American who became the first human to see the Earth from the surface of another world. 8 years and 2 months on from Kennedy's commitment, Buzz Aldrin poses for the picture of the century. And with Neil Armstrong's small step, the space came to an end.
The engine's now building up to 7.7 million pounds.
All engines running. Launch commit and liftoff.
We have a launch commit and we have a liftoff. The swing on.
Over the next 3 years, 10 more astronauts set foot on the moon, making it America's own.
Andy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail. He makes sharp turns. Makes you proud to be an American, Tony. Look at the size of that pickie. It is a pickie, isn't it? It may be further away than we think. No, it's not very far. It was just right beyond you. You just covered it up. Got it. I got it.
The astronauts found that the moon rocks were rich in valuable minerals like titanium and aluminium, metals which could form the basis of a profitable moon mining industry in the future. The astronauts' geology training certainly paid dividends.
Here you get permanently shattered soil. How about rolling that one over? No way. As you come around there, there's a rock in the near field on this rim.
They poked and prodded its surface, took its temperature, and monitored it for moonquakes. All the evidence suggested that the moon was as dead as a dodo.
Again, home again, jiggity jig.
But hostile though the moon undoubtedly is, the astronauts showed us that it is possible for us to live and work on another world.
What a ride, what a ride.
In 1972, man left the moon for the last time and headed homewards to the blue planet. Man brought back with him not just rocks for the geologists on Earth, but also questions about the moon that are still, at the moment, unanswered.
Sort of ultimate question is, where does it come from? That's almost a religious question, because There are the ideas that it formed at the same time as the Earth, that it was pulled out of the Earth, that it was captured. It was an asteroid that came by and the moon grabbed it. All these ideas are still in very active contention. The latest idea is that a great impact took place, and the splash from this impact is what went out and formed the moon.
And will you find out by going back?
Yes, we think so, because it should leave its traces, and we can have chemical and age data that would help settle this question. But as in most religious issues, it will probably engender a great deal of debate.
And another debate is simmering. Fired by the discoveries of amateur astronomers, some scientists take seriously the notion that the moon isn't dead.
Aristarchus is looking bright tonight.
The Cook family wouldn't be the first amateur astronomers to upset the professional apple cart.
All that detail from here.
It's amazing. They say the moon is completely changeless, but when you look at it through a telescope like this, you can see differences. Now, you're an amateur family of astronomers, and you've been looking for how long?
About 12 years, I think, and it's amazing the sort of things that we can see. I mean, we've really got the time to observe the moon.
The Cooks have taken extraordinarily good photographs of the moon's surface. And like many amateur astronomers who keep the moon under scrutiny night after night, they've observed unexpected changes there.
There's a lot of colour that you observe. Some of it is to do with the atmosphere, but there is some colour that we feel is not to do with the atmosphere.
What's going on? Well, it's very difficult for us to know. Really, what we're doing is we're observing and we're reporting what we see. It could be due to sort of little moonquakes, could be due to little emissions of gas disturbing the moon dust. It could be a lot of things.
Landslides, I feel, sometimes too, which would cause obscurations, which we do see quite often.
So it's beginning to look that despite what we...
Little emissions of gas disturbing the moon dust. It could be a lot of things.
Landslides, I feel, sometimes too, which would cause obscurations, which we do see quite often.
So it's beginning to look that despite what we've all been taught, people like you who are able to look at the moon every night are beginning to tell us that the moon isn't perhaps quite as dead as we have learned to believe. Is that right?
Oh, you're absolutely
Let's
right.
have another look at it, shall we?
That's right.
Wow. You can still see that bright rim along the edge of Aristarchus.
We have reached the moon, but we've hardly begun to explore it. It's still a place of challenge, a world which is in stark contrast to its companion, the gentle, living blue planet. Most of all, the moon has been an inspiration to us. It has led us to reach beyond our own planet, to aim towards our fellow worlds, and perhaps one day, further still.
See unbelievably big sea monsters. See man-eating bugs bigger than buildings. A spectacular adventure on the angry red planet.
Of all the planets, Mars is the one that people most associate with life. Aliens, bug-eyed monsters, but most of all, of course, intelligent Martians. And it's not just nutcases who think that. When astronomers first turned powerful telescopes towards Mars, they found indisputable evidence.
In 1877, when Mars was very close to Earth, I observed it through my telescope. I have seen innumerable canali. At times, they appear to become double. They are very long and straight. Is it possible they are artificial?
These words fired the enthusiasm of a rich American. Percival Lowell became obsessed with Mars and devoted his life to investigating it. Using his family fortune, he built an observatory under the clear skies of Flagstaff, Arizona, and it showed him astounding things. He saw Schiaparelli's canali, straight dark lines crisscrossing the red deserts of Mars. He reasoned only intelligent beings could have designed such an organized system, stretching from the polar caps of Mars to the central plains.
It is evident to me that the Martians, endangered as they are by water shortages, are a peace-loving people with a planet-wide democracy. They have built a network of canals to irrigate their dried-up world, and these are a wonder of engineering.
all the planets, Mars is most like the Earth. It's a bit further from the Sun, so that Mars is a bit chillier. But even so, a Martian summer could be as warm as a winter on the Earth. So it wasn't all that surprising that Mars might have some kind of life. Through Earth's fuzzy atmosphere, details on Mars are elusive, even through the world's biggest telescopes. But there were white patches at Mars's north and south poles, just like the Earth's polar ice caps. And although not all astronomers could see canals, many made out dark patches that shifted with the seasons. Surely it had to be vegetation. But no one really knew. Everything had to wait for the space age. These early Mariner spacecraft sent back our first fleeting pictures of another world in close-up. And sadly, they revealed that Mars was no lush paradise of life. It appeared to be a barren world pitted with craters and almost devoid of air. No sign of Lowell's canals, and the shifting vegetation turned out to be wind-blown dust. As far as life was concerned, Mars seemed a dead loss. But in 1971, America's Mariner 9 showed a new Mars, the site earlier probes hadn't photographed. There were huge volcanoes and gaping chasms, and strange, sinuous valleys which, although now dry, could only have been cut by running water. If there was water, there could be life. And so, with optimism running high, biologists and astronomers got together to design the ultimate spacecraft, one which would soft land on the sands of Mars and search for signs of life. The two Viking landers were the most sophisticated spacecraft ever designed. At the end of a robot arm, each had a scoop for Martian soil samples, which it could place in a tiny laboratory for analysis. Meanwhile, the Viking's cameras would scan its surroundings, and a small radio dish would manfully relay all the pictures and data back to Earth. This particular Viking was road-tested in some of the harshest deserts on our planet Earth, and so scientists thought they knew what to expect.
But what kinds of life forms might cope with the special problems of Mars? The Mars atmosphere allows deadly ultraviolet radiation from the sun. Life forms on Mars may have silica shells to protect them against the radiation. We know that Mars is very dry. Life forms on Mars may have developed special ways of preserving their water content, and those forms may not look familiar to us. I could imagine a kind of plant that is indeed an ice eater, with fine root-like structures, searching not for liquid water, but searching the permafrost, reaching down to get at that ice.
In those very early heady days, there were some people who thought we might find visible signs of life, maybe be able to take a picture of life. That was pretty fanciful, but it was possible. But for the most part, we were looking for things that were very small, tiny, below the level of the human eye, that you would have to, we didn't carry a microscope, of course. We really took chemical kinds of experiments. We took small samples of the soil and looked for the kind of things that biology do.
4, 3, 2, 1, separation.
July 1976, and hopes are high as Viking 1 approaches Mars. At Mission Control, scientists follow the lander's descent with bated breath.
We were at the command center at the Jet Propulsion Laboratory in Pasadena, California, where all of the teams had, of course, assembled for the mission. And as we heard over the speakers and watched our monitors the various altitudes of the spacecraft, why, we were sort of very excited and filled with great anticipation.
Points range of 2,600 feet, 188 feet per second.
2,600 feet.
366 feet.
73 feet per second.
ACS is close to vertical.
Nav is green for touchdown.
ACS is green, 1.5 degrees per second max, 0.2 Gs, 3 feet per second.
Touchdown, wind.
The 5 years of planning paid off. Viking was safely down and ready to begin its first-hand inspection of Mars.
Yes,
The first pictures didn't come back until about 30 to 35 minutes after landing, so that was a long time that we had to wait to know whether the cameras were actually going to work. And it was a suspenseful time as we waited. And then when the pictures started, they were painted on the monitor a line at a time, and so it was we had to wait and watch the picture as it unfolded, and that was quite exciting.
Elliot, what did the pictures show us?
Well, the first picture was planned to take a scene from one footpad to the other so we could see what the surface was like and what interaction this footpad had with the surface. Then the next picture was a panorama that took the horizon, and that showed us what the far field looked like. The horizon on Mars, since it's a smaller planet than Earth, is only several kilometers away. And on the horizon we could see the rim of a crater and some large rocks of various types, a very rocky scene. There were rocks several meters across on the rim of a crater on the horizon. And then there was one about 9 meters from the spacecraft. There was a large rock that we called Big Bertha, but we changed the name to Big Joe because some of the ladies didn't like Big Bertha.
But Viking didn't just see Mars in black and white. Within hours, the first color pictures of the red planet started to come in.
First, we expected the sky to be somewhat here on Earth, because it has an atmosphere, so we thought it would be kind of bluish. But as we processed the colored pictures, we discovered that the sky was pink. And the reason it was pink was because a lot of that red Martian dust is still in the sky, which give it that pink color.
Viking had a lot more to do than just send back holiday snaps. Its long scoop, here being tested on the Earth, was designed to feed the Martian soil into a miniature laboratory which would check for signs of life. The whole operation had to be done by remote control. But how would Viking recognize life? It was designed to look for organics, chemicals which would form life given half the chance, and also for microscopic living cells in the Martian soil.
And what kind of things did you detect coming off in these experiments?
Well, that was a surprise. In fact, there were two remarkable surprises in Viking. One was the fact that we didn't find any organics, any of these chemicals that life is made, and that really perplexed us. How could there not be any organics, since there was every reason to think that we would find organics that came from meteorites or that came from just the synthesis of the normal chemistry of Mars, but not finding any was very surprising.
How weird.
In one of the experiments, a really surprising thing happened. We call it the chicken soup experiment, where we dumped a bunch of stuff in there, hoping that if there's a Martian organism there, it might like to eat the chicken soup. It wasn't really chicken soup, of course. But to our amazement, what happened is oxygen started coming off, as though there were some very funny thing breathing out a lot of oxygen.
On board the lander was a miniature laboratory, no larger than a big waste paper basket. It contained 3 automatic experiments. The chicken soup experiment was designed to look for the activity of living cells in the soil. A small amount of nutrient, the chicken soup, ran down to the bottom of the container. It gave off water vapor which moistened the soil. At this stage, any cells present should not have responded. But to the scientists' surprise, the moistened soil very quickly produced lots of oxygen gas. And then as quickly as it had started, it suddenly stopped. Was it life that had produced this sudden burst of oxygen?
Well, the current explanation is that probably there are these peroxides on Mars.
That's the kind of thing you put in your hair to make it blonde?
Yeah, that's right. The kind of stuff, probably not hydrogen peroxide, which is the kind you find in the drugstore or in the pharmacy. Probably iron oxide, since there's a lot of iron on Mars. But does the same thing. It's highly oxidizing, and in some ways, I guess you might say, it tends to sterilize the surface. It destroys those organics that ever get started.
So if life chemicals are so common in space, they're common on the Earth, they're common in meteorites, they're common way out beyond the solar system,
why aren't they on
Mars?
Right, great question. Wish we knew the answer to that. That's why we're going to have to go back again and answer all those questions.
closest we can come to Mars on Earth is in a barren desert like this one. In fact, to look at, the two are very similar. The same pinkish-coloured soil, the same dark volcanic rocks. But Mars is a great deal more barren.
The Viking landers have shown us that, life or no life, Mars's soil has a peculiar chemistry. Its thin atmosphere has no protective ozone layer, unlike here on Earth. Without this sunscreen, the merciless ultraviolet rays of the sun beat down unchecked, sterilizing the Martian soil. In the past, conditions may have been kinder, and life may have started. But without an ozone layer, it would have had a mighty struggle to survive.
While here on Earth, our sunscreen protects life. And as a result, it can flourish in even the most unexpected and hostile environments.
Meanwhile, pictures were being received on Earth from the two Viking orbiter craft high above the Martian surface. Over a period of 6 years, they sent back thousands of images. And as a result, we know the face of Mars today more thoroughly than that of any other planet, including our own. Even though the Viking mission is over, we are still learning more from the data as our computer power increases. With the computer's aid, we can fly over Mars's huge volcano Olympus Mons, 3 times the height of Mount Everest. That's something which would have been undreamt of when the mission first started. We can survey the ins and outs of the planet-wide Valles Marineris canyon system, a system so big that it forms a vast scar on Mars's surface. The Valles Marineris is one of the prime targets for when we next go to Mars.
We have a long way to go and lots of steps to fill in before we send people. For example, we got lots of pictures with Viking, and we have beautiful pictures of local areas, and we're drawing geologic maps of those showing where the rocks are. But we didn't have chemistry. So the next thing we do is we send an orbiter to determine what the chemistry is. That's sort of a mid-year exam. You see, we've drawn these lines that says what the chemistry is, and we'll find out whether we pass or flunk. And then the final exam is when we send a lander with a rover that runs around and collects samples that we bring back. And that's the final exam.
Will this rover be manned or unmanned, Hal?
We could do it either way. We could take the pictures and the chemical data and send the unmanned rover and say, you know, stop here and pick up samples. We'd like to do it with a man because a man is cleverer and more flexible, and we're looking for very subtle things like soil horizons. And the man could go just to the right place to pick the right samples up.
In Tucson, Arizona, a prototype for the first unmanned Mars rover is taking shape.
Yeah, the relief valve is operating. We got about 24
It's not being designed by a giant aerospace corporation, but by a group of students commissioned by NASA.
There have been designs which have had sort of small wheels and intelligent sensor systems and intelligent decision-making programs, but that costs a lot of money, and the idea of this is it's much cheaper if it doesn't need that intelligence. If we have these huge wheels, we don't have to be that fussy about where we can just drive over most of the obstacles on the planet.
How fast will it move over the Martian surface?
About
a kilometer a day.
Kilometer a day? Rolling a lot.
Yeah.
Okay, so you can see each one of these valves goes to a sector, and like we saw over there, and can either inflate or deflate it. And then we use the computer to tell it to roll in different directions.
A small model of the Mars ball shows off its paces on the University of Arizona campus. The actual vehicle, if it ever gets there, will stand 16 feet high.
I don't like to ask this question. What happens if one of those gets jammed?
Well, we don't like to answer that question. If it happens when we're testing it in Arizona, we can just go out and hit it with a hammer. If it happens on Mars, we may be in trouble. That's why it would have to be very carefully designed.
We need Martians to help you.
That's right, yeah.
Should man ever go to Mars, he'll certainly face problems. For a start, there's the distance. The round trip takes about 2 years, and that's one reason why the Russians, in their Salyut space station, are experimenting with long-duration spaceflight. What's the effect of weightlessness on the human body over long periods? And can you wash away the psychological problems of living in space in a space station shower? Worst of all, space gets into your bones in the most insidious way. Prolonged space living makes your bones brittle, and although vigorous exercising lessens the effect, it won't go away. But we're getting there. Russian cosmonauts have managed to live in space for periods of nearly a year. They claim that within 15 years, man will set foot on Mars. At a secret location in England, even longer-term plans are being laid.
It's pretty clear that the scientists have done their homework on ways of keeping people alive in spaceships, but we don't think that the social scientists have done their homework very well. I mean, we actually don't know whether a mixed group of people are going to be able to live together in harmony for the duration of some of the early settlements on another planet.
A group of English social scientists is persuading 15 volunteers to give up a year of their normal lives to live in a complete simulation of a Martian base. As they work, rest and play, their every action will be watched by television cameras that record how people actually get on with each other under the very demanding conditions that real Mars settlers will suffer.
What about pleasures? Will they have any fun things to do?
Oh yes, we'll have a library of tapes of entertainment and music and films and things like that, and they'll also be able to phone home. But
are there other problems there?
Well, there is one very big problem. There's a 60-minute delay, which we'll have to construct an artificial delay, which might cause problems.
When is all this going to happen?
Well, we're hoping it'll get going in about a year. It'll take a lot of planning, and it'll also take a lot of money.
This idea is not as bizarre as it sounds. Scientists are already using the Viking data to select possible sites for a base on Mars.
Hal, what do you think of the idea of establishing a manned Martian base?
It may seem far-fetched, but it's entirely feasible. The biggest thing is that unlike the moon, Mars has lots of water, and that's what we need for life.
So where would you put this base?
Well, the easiest place, that is where water is most available, is near the North Polar Cap, which is lots of water ice. And all you have to do is use solar heaters and melt it.
Well, you've mentioned all these missions, like the Observer, the roving vehicle, a manned flight, and possibly even a colony one day. It all sounds like science fiction. When's all this going to happen?
Well, it would take a lot of time because we have to do it one step at a time. We have approval for the Mars Observer mission to determine the chemistry. That flies in 1990. There are people who think that we might fly a lander rover sample return mission in, say, the mid-1990s, 1995, 1996, and perhaps a manned mission 10 years after that, and the Mars base 10 or 15 years after that. That sounds like a very long time, but we have to build this a step at a time, and if we intend to go in that direction, we have to make the plans now. When we first talked about these very long missions, one of the people said, "My goodness, I won't be around. It will be the sons of my graduate students. It'll be a new experience in human history." And I said, "Remember the medieval cathedrals? They took 200 years to build."
There are plenty of mysteries left for future missions to Mars, and the question of life is still top of the list. We know that Mars's soil has been thoroughly sterilized by the sun's radiation. But did life ever develop during Mars's warm and wet past? Might scientists one day find fossils buried deep in the ancient rocks of Mars's giant canyons?
Some of us feel that, well, some of us, I sit on both sides, feel that maybe there never was life on Mars. Maybe it was always this way. And others feel it's possible that today's Mars is different than it was, say, 2-3 billion years ago. I think we're not going to know until we actually carry out the right experiment.
And go there?
Right. I think the only solution, as science always does, is you have to do an experiment. You have to go there. You either have to have people there, or you have to have spacecraft there that actually go look for fossils or look for meteorites or look for something. Until we have exhausted ourselves, we just won't know the answer to that.
Well, let's wish the next generation the best of luck in getting there and finding out.
Give them everything.
So Lowell decided to start an observatory.
They might find fossils when they get there, but they won't find Percival Lowell's canals.
The longer he looked at Mars, the more of these lines that he thought he saw. And so he thought that they were canals. And this meant there must be people on Mars to build these straight canals. But it turns out that all Lowell was really seeing was just an optical illusion through the eyepiece. It could be that his eyes just wanted to draw lines between the dark and light areas on the planet, or possibly the optical arrangement of the telescope was accentuating that, was making the light areas lighter, the dark areas darker, and was making him think he saw those lines when they weren't really there.
Perhaps Percival Lowell did get too carried away by his own enthusiasm for Martian canals. But his conviction about life on Mars was the spur to research leading to the Viking landers and to the next round of American and Russian spacecraft that will photograph Mars and roll around its bare deserts. And beyond that, we can look forward to the day when there will be intelligent beings on Mars. Not little green men or bug-eyed monsters, but settlers from planet Earth.
And most encouraging of all, our future exploration of Mars is now becoming more international and more collaborative. The Russians and the Americans are openly speaking to each other about their plans, and already they're keen to collaborate over certain details. Mars may well be the red planet, but let's hope it's not just a Russian cosmonaut, but an international team who become the first Martians of the future. It would certainly make Percival Lowell a very happy man.
Is it like a spaceship?
Looks like a spaceship.
I don't even know what it is.
It's a planet, yes.
No, so far they're getting too much back. Come on.
Yes, that's right.
Come on, what we go?
That one there. What do you reckon on that?
I can see a ring with a blob in the middle. It's a blob.
It's a blob. You're into blobs, you lot, aren't you?
And it's got a ring around it.
Uh-huh.
It looks green to me.
Today we could do much better than just stand and stare. Okay, the view through a telescope's all right, but it's continually blurred by the shifting of our atmosphere. Nowadays, we, or rather our instruments, can actually go there by space probe. Already, 4 probes have visited the planets of gas. There were tantalizing discoveries. Rings around Saturn which apparently defied the laws of nature. Gigantic storms on Jupiter many times bigger than the Earth. And, most unexpected of all, a whole system of encircling new worlds. Worlds of ice and worlds of fire. At heart of our solar system are 4 small solid planets. Jupiter and Saturn are the first of the outer planets, worlds quite unlike our own. To us, the Earth seems vast, but compared to Jupiter, in fact, Jupiter's bigger than all the other planets put together. Saturn is only slightly smaller, but its rings would nearly bridge the gap between the Earth and the Moon. Both these huge planets have been easy targets for telescopes since the days of Galileo, and it's astonishing how much astronomers were able to find out. Galileo himself found that Jupiter wasn't alone. It's circled by 4 moons, big enough to be planets in their own right. Here was proof that not everything circled the Earth. And incredibly, only decades later, Ole Rømer timed these scurrying specks and came up with the first accurate estimate of the speed of light. Over the years, astronomers discovered Jupiter was a very different world from the planets close to the Sun. They were even able to work out what lay beneath its swirling clouds. They deduced that most of Jupiter is an enormous globe of hydrogen and helium gas. Deeper still, under huge pressure, the gas becomes a silver sea of liquid metal. And right at Jupiter's heart, there's a super-crushed rocky core, glowing red-hot in the darkness. In short, Jupiter is a giant gas bag. Distant Saturn is a smaller version of Jupiter, but not quite so dense and compressed. In fact, it could float on water, given an ocean large enough. March 1972. The start of the longest journey ever made as the first of 2 Pioneer probes heads off towards Jupiter and Saturn. It's a voyage into the unknown. But the launch rocket isn't powerful enough to send Pioneer all the way to Saturn, and so the flight involves an untried maneuver in interplanetary ballistics. Using Jupiter's gravity to speed it up, Pioneer would be looped around the giant planet and flipped back across the solar system in a 4.5-year journey to rendezvous with Saturn. It was to be the cosmic equivalent of scoring a hole-in-one from 50 miles. And even as the Pioneers are hurtling across the solar system, space scientists are busy constructing the next generation of explorers, purpose-built to investigate the outer planets. These were the Voyager probes. December 1973. Cameras rolling, Pioneer 10 becomes the first spacecraft to approach Jupiter. As it closes in at 40,000 miles an hour, it encounters a mysterious zone of intense radiation. With the Voyager craft close to completion, scientists had to do some quick thinking, as Brad Smith recalls.
That was the unexpected. That was this extremely intense radiation belt around Jupiter. So intense that, in fact, it would have destroyed the Voyager spacecraft. After Pioneer told us about it and told us how severe it was, we were able to make some design changes in the spacecraft and the instruments so that we survived quite well.
Pioneer lived to tell the tale. In its quick loop of Jupiter, it sent back our first glimpses of the planet's swirling clouds.
Well, they told us that the atmosphere of Jupiter was rather more complex than we had deduced from our ground-based observations. And so we were somewhat prepared for it, but Voyager showed an even more complex system than Pioneer had hinted at.
The Voyager craft had been saved from an ignominious end by the trailblazing Pioneer probes. And these new craft were built to go much further and give far more information than their predecessors. The 2 Voyager probes could actually think for themselves without always having to rely on a command from Earth. On board, they had 3 computers make up a kind of robot brain, as well as TV cameras and dozens of other instruments. And the pictures they sent back from Jupiter were absolutely incredible, the best to date. 2 years and 400 million miles later,
Voyager 1 draws close to the king of the planets. In the last few days of its approach to Jupiter, its cameras produced a time-lapse record of the turbulent planet through a cloud-enhancing blue filter. Most stunning of all, Jupiter's great red spot, a mysterious oval first seen 300 years ago. Voyager reveals it as a huge weather system, 3 times bigger than the Earth. Years and 400 million miles later on its epic journey, Voyager recorded the spinning rings of Saturn. And with computer enhancement, the pictures show tongues of swirling cloud whipped along by the fastest winds in the solar system. Saturn, too, has its own red spot. Voyager's pictures are helping towards our understanding of the solar system.
These large planets are still contracting from their birth 4.5 billion years ago. That contraction is still going on, very, very slowly. And that compression of the planet releases heat from the interior, which works its way out.
And is the same true of Jupiter?
Yes, in fact, in the case of Jupiter, all of the heat that's coming from the interior is due to that contraction. But Saturn is a little different. It's some separation of the helium and hydrogen that produces an additional amount of heat.
And presumably on both Jupiter and Saturn, it's this heat that drives around the atmosphere.
Yes, that's the mechanism that drives these enormous weather systems that we see on both of these planets.
So the ultimate cause of Jupiter and Saturn's turbulent atmospheres dates back to their birth 4.5 billion years ago. The planets were formed in the gravitational collapse of a great cloud of swirling gas and dust. The gravitational energy of this gas and dust falling inwards heated the planets as they formed. Jupiter and Saturn have not yet cooled off. They give off far more energy than they receive from the Sun, and it's the heat from their compressed cores that powers their violent storm patterns. But there was more. As Voyager flew round Jupiter, it made a startling discovery. Its cameras turned back and revealed a faint, thin ring of countless tiny rock splinters. But Jupiter's ring is the palest shadow of Saturn's glittering tiara. Earthbound astronomers could only see 3 rings, but Voyager revealed literally millions. Voyager couldn't fly through the rings, but it had an instrument on board to measure how wide and how thick they were. As the rings passed in front of the distant star Delta Scorpii, its light intensity flickered, and scientists got their chance to make measurements of the ring system.
We now know that they're only perhaps tens of feet thick in places and hundreds of thousands of miles across. If you were to make a model of the rings, the thickness of a sheet of paper, for instance, you'd have to get a piece of paper about, a half a mile in diameter in order to make that. So you've got a very, very flimsy, very, very thin ring system around Saturn.
The rings are so thin you can actually see through them. So what could they be made of?
Well, we think they are made of water ice, but because their colors are slightly different than the color of just plain water ice, we know that there's some contaminating material mixed in with the ring particles. The particles probably range in size anywhere from dust-sized particles to the size of a house.
Saturn's ring system was full of surprises. When Pioneer 11 had shot past the planet, it sent back a blurred picture of a new, thin, mysterious ring at the outside edge of the system. Voyager's more detailed photographs showed that this ring appeared to defy all known laws of science. In close-up, it appeared to have kinks and twists. But now we know why.
It's called a shepherded ring. That is, there's a satellite just on the inside and just on the outside of this ring. And those two satellites tend to confine the material in a very thin, narrow ringlet. In fact, the motions of these satellites, because they don't orbit Saturn exactly in circular orbits, tend to tug on the ring particles and actually create very strange and exotic shapes, much like a braided pattern.
It sounds rather like dogs herding sheep and making sure they stick to the middle of the road.
Exactly, and it's one of the mechanisms that was uncovered to understand some of the ring structure.
So perhaps there could be other small satellites splitting the system into millions of rings, making Saturn the grooviest planet in the solar system. The trip past Jupiter and Saturn was the first opportunity to examine, in close-up, moons visible from Earth only as tiny specks. Voyager reveals strange new worlds, and at Saturn, far more than had ever been expected.
Before Voyager, the number of moons was something in the order of 10 or 11. There was a little bit of controversy there as to whether there were one or two in a particular orbit. And Voyager has now brought that number firmly up to 17. That is, we know exactly where they are at all times. Their orbits are very well determined.
And that's the record, isn't it, for any planet?
That's certainly the largest number of any planet, of the satellite moons that have yet been discovered.
So Saturn can boast the largest family of moons in the solar system. Most of Saturn's moons are just airless balls of ice, battered and scarred with craters. But there was one astronomers really wanted to see, the giant moon Titan. They thought it had an atmosphere, the only moon in the solar system to have one, and hoped to see close-up views of its surface. Titan does have an atmosphere. Thick orange clouds cloak its surface, clouds so thick cameras couldn't penetrate them, and its secrets remain hidden. When Voyager swept past Jupiter, it took family portraits of its 4 biggest moons, the moons first seen by Galileo. Turning its cameras on Ganymede, a moon bigger than the planet Mercury, Voyager showed us a world festooned with ribbons, mysterious groups of parallel grooves and ridges trailing over the moon's surface. Jupiter's crater-scarred moon Callisto sports an enormous bullseye, the legacy of a direct hit by a huge meteorite. Flying past Europa, Voyager discovered it was made almost completely of ice and smoother than a billiard ball. Its surface is crisscrossed with narrow cracks. Some scientists speculate there could be liquid under the ice, harboring primitive life forms. But if the findings on the other moons had been a surprise, then hot-blooded Io came as a shock. The first pictures of Io revealed what the Voyager team thought was a cloud. But to everyone's amazement, it turned out to be a huge volcanic eruption.
lakes of molten and solidifying lava spot its surface. Its appearance is changing almost daily as new eruptions spray fire and brimstone into space. Io is the only world, apart from our own, on which volcanic eruptions have actually been seen. Io's volcanoes spew clouds of gas, much like Earth's geysers spray plumes of steam. Sue Kiefer is a geologist who's been studying volcanoes both on Io and on the Earth.
Sunset Crater and most of the volcanoes on Earth are made of a melted rock that we call magma. The volcanoes on Io are made of sulfur and sulfur dioxide.
And when they erupt, how high does the eruption go?
Some of the tallest eruptions go 250 or 300 miles.
Incredibly high. How does that compare with Earth?
Well, most of us have seen Old Faithful Geyser in Yellowstone. On Earth, Old Faithful erupts to about 100 feet in height. If Old Faithful were on Io, which has a lower gravity and a negligible atmosphere, it might erupt to almost 25 miles.
That's incredible.
Well, it might have been discovered as a small volcano by the Voyager spacecraft.
Once Voyager had found the volcanoes, astronomers turned their telescopes on Io. They discovered the eruptions leave behind a trail of gas which could be photographed from Earth. These gases spread out to form an invisible ring around Jupiter, displayed here in computer graphics. And other things lurk in the apparently empty space around the giant planet. Mighty electric currents circle endlessly under the influence of Jupiter's powerful magnetic field. This magnetism is generated deep in Jupiter's heart and extends millions of miles into space. Following the tilted magnetic axis of Jupiter, the huge magnetic cage swings and sways in the ocean of space. The space probes gave us our first close-up look at these outer worlds, worlds we thought we already knew. But there was far more to see and learn than we could ever have guessed. The swirling clouds of Jupiter and the mighty rings of Saturn harbored unexpected secrets. More than anything, it was the moons of both planets, in their number and variety, which really intrigued the scientists. It had been like discovering two new solar systems in miniature. When space shuttle flights start up again, after the long grounding which followed the tragic loss of Challenger and her crew, we'll be going back. A giant catapult on board the shuttle will launch the probe Galileo on what will be our next visit to Jupiter and its moons. While it was still under construction in a room pumped free of all dust, I was given a guided tour of the spacecraft by Torrance Johnson, the chief project scientist.
The bulbous bit sticking out.
Yes, large tanks for the propulsion system. That provides both the attitude propulsion.
Although carrying far more instruments than its predecessor, Voyager, Galileo somehow had to be built to fit in the shuttle.
Well, this is the main communication dish for the entire spacecraft. And it, of course, has to be very light and flexible so that it can fold up inside the space shuttle.
The stuff it's made out of looks like sort of stocking material, doesn't it?
In fact, it was woven on the same type of machine that is used to weave pantyhose.
Galileo is two spacecraft in one. As it nears Jupiter, it will release a small probe to investigate the depths of the planet's turbulent atmosphere.
got the probe.
Amazing.
And as you can imagine this thing hitting the atmosphere of Jupiter at a little over 100,000 miles an hour.
Oh, I'd rather not.
It descends on a parachute, going approximately 100 miles into the atmosphere of Jupiter, radioing data back to the orbiter flying overhead. And then eventually, after we stop listening to it, the pressure and temperature of the Jupiter atmosphere will get to it, and it will be crushed, vaporized, and actually become part of Jupiter itself.
Meanwhile, the main craft will become a man-made moon of Jupiter, probing the intense radiation belts and returning for another look at those tantalizing moons, first observed by Galileo himself almost 4 centuries ago. The crater is so vast you can see it from space.
Well, fortunately for us, impacts as big as this are pretty rare nowadays. And that's because meteorites, and indeed comets, are pretty rare as well. They're bits left over from when our solar system was born a very long time ago. But when a meteorite does land, it's great news for astronomers, because if they can pick up a meteorite, they can sample some of the first material which gave birth to the sun and planets a very, very long time ago.
By analysing meteorites in microscopic detail and finding their exact age, scientists have revolutionised our ideas on how the sun and planets were born. We used to think that the birth of the planets was a chance event. A passing star pulled a filament of gas out of the sun, which later cooled to create the 9 worlds of our solar system. But the evidence from meteorites tells us that the planets came into being as a natural consequence of the sun's birth. 4.5 billion years ago, deep in a spiral arm of our Milky Way galaxy, a cloud of dust and gas began to collapse under its own gravity. As the collapse continued, the cloud spun faster and faster until it formed itself into a disk. At the center, where the gas was densest and hottest, our sun began to form. Further out, the dust particles form the beginnings, the cores of the planets. In the outermost regions of all, the gas was cool and slow-moving, and so these young planets were able to swathe themselves in huge atmospheres. The solar system, as we know it today, was taking shape. Meanwhile, at the heart of things, the sun was getting even denser and hotter. And one day, it burst into life. Nuclear fires ignited in its core, where they still burn to this very day. That first surge of energy blew away what remained of the gas cloud. All that was left were 9 planets and billions of tons of cosmic debris. Some of this rained down on the airless innermost planets, scarring them with craters of all shapes and sizes.
Almost certainly that's how the sun and the planets were born. In fact, we're still seeing the last sequences in that story today. Debris still rains down onto the Earth, and comets zoom in from the outer parts of the solar system where the relics of the old gas clouds still stand. And when we look out beyond the solar system, we see that many newly born stars are surrounded by gas clouds of their own, very much like the one which must have surrounded the sun in its early stages.
Looking deep into space, we can see the past and future of our own sun. Space is far from empty. All around are gas and dust, the raw materials from which stars can be born. We can see nurseries of infant stars, and the dying remains of once mighty suns. Now we know that the planets of our solar system were born at the same time as the sun, we start to wonder if other stars are born with planets too.
But the mysteries of starbirth are hidden from the gaze of ordinary telescopes within huge shrouds of dust. In 1983, a revolutionary astronomical instrument went into orbit about the Earth. IRAS was an infrared telescope in space, and it saw the universe in a new light. When IRAS looked at the great dust clouds in Orion, it could see through the dust to a cluster of giant stars being born within. In another dust cloud, it picked out the birth of a single star just like the Sun, but too far away to be able to see any detail. That had to wait until IRAS's infrared eye was turned on the brilliant star Vega.
And one of the most exciting discoveries by IRAS was, in fact, that stars, close stars like Vega and Beta Pictoris, actually have shells of material, disks of material in orbit around them. Material that might well be the building blocks of planets. The amount of material is fairly hard to pin down, but it's something around a few Earth masses, maybe as much as the mass of the planet Jupiter, in orbit around one of these stars. And we see a faintly glowing heat coming from this star that can only be explained by a shell of material like this.
So IRAS saw cool matter around Vega, but it didn't look like our idea of a solar system. IRAS, however, had seen several similar stars, and two astronomers took a closer look at one, Beta Pictoris.
Brad Smith and I decided to follow up on the IRAS result of material around other stars. We used an ordinary telescope and some rather sophisticated ground-based instrumentation to look at Beta Pictoris, one of the IRAS stars, and found it was surrounded by a disk of material, flattened disk, indicating the material was in orbit around the star, something like 10 or 20 times larger in extent than our own solar system.
This is the first picture of a solar system beyond our own. By blocking out the glare from the central star, they were able to see the faint glow of its disk, seen edge on. But what was it made of?
Ice is almost certainly the composition. There may be some rocky material mixed in with it, but it's almost certainly ice. And it is, in fact, almost certainly the very same material that was around the Sun 4.5 billion years ago when the planetary system formed.
You're trying to say it's the solar system in formation?
We are, in fact, saying that it is a solar system either in formation or actually perhaps already formed. In other words, what we may be seeing is the debris that's left over after the formation of a planetary system around Beta Pictoris.
So there could be planets in there as well?
Yes, there's no direct evidence at this moment one way or the other, except to say that when you have that much material, it's almost impossible to conceive of planets not forming. So the probability, although we can't detect them, is very high that Beta Pictoris is surrounded by planets, and then what we see is this big disk of leftover material that didn't get into the planet formation.
Beta Pictoris is a star which in many ways is very like our Sun. What's the possibility of finding these kinds of things around other stars?
Yes, I think that's what's so particularly interesting about this discovery. When we start thinking about the possibilities of life elsewhere in the galaxy, in the universe, the question is our own solar system unique? Is it very rare to find a star with planets around it? And we had no idea whatsoever what the answer was to that question. Now we have found another rather nearby star with a disk around it which almost certainly indicates planetary formation. And if there's such a disk around Beta Pictoris, there are undoubtedly many other stars as well, and that would say that star formation or planetary formation go together, and that planets may be very, very common throughout the galaxy. If planets are common, then the possibility of life is very much increased, and it says that there's probably a very good chance that we're not alone in the universe.
It's a long way, though, from seeing a disk of matter around a star to finding an actual planet, a place on which life might exist. The problem is that a planet is small and dark, and it's almost impossible to spot against the dazzling glare of its sun. But astronomers are a resourceful breed. By using infrared, they can turn down the contrast between a planet and its star. Peak Observatory in Arizona, astronomers have equipped one of the largest telescopes with an infrared detector. For years, they've been trying to pick out planets circling the nearest stars in space. And finally, With a faint star unromantically named VB8, they think they've succeeded. For the first time, man may have discovered a planet around another star, and the man is Don McCarthy.
Well, I saw two objects that were close together, about an arc-second apart, and differing in brightness by a factor of 20 or so in the infrared. VB8 is thought to be one of the lowest possible luminosity stars, right at the limit of what a star is. And so finding another object that close and yet 20 times fainter than VB8 already indicates that the two are physically associated and that the fainter object can't be a star.
Don's infrared camera scanned across the star VB8 in two directions. In both directions, it showed a second blip. It had to be a planet, and it was given an even less romantic name than its sun.
Well, we call it VB8b.
That's boring. Couldn't you come up with something a bit better than that?
I have received a lot of letters from school children all over the country who have very interesting names proposed. Hesperios and Vulcan, and some names have already been used.
Vulcan's a good one.
That's right.
Our own planet, Jupiter, bears many resemblances to VB8b. Both generate their own heat because they're so very massive. It's this telltale heat which allowed the infrared camera to track down VB8b. But we know that planets like these can't support life. Do you hope eventually that you'll find planets like the Earth around other stars?
Well, that's the hope, but it's very difficult to directly detect the light from an Earth-like planet, because there you're not seeing its heat so much as its reflected light. And an Earth-like planet is very small and would not reflect much light. So I think in the immediate future our goals are to detect the heat from larger planets. And the search for Earth-like planets can be accomplished by doing more of the astrometric measurements, where you're not looking at the planet itself, but the motion of the star that gives away the planet. And that's possible from space, too.
The task of finding another Earth circling round a distant star seems almost impossible. It's well beyond today's technology. Even the next generation of telescopes in space will probably only find more gas giants like Jupiter. But the idea of our finding a celestial twin is so enticing that astronomers are unlikely to give up. One day, we may find a whole set of planets orbiting a star, and the future astronomer who explores them will be like Goldilocks, looking for one that's not too big, not too small, not too hot, and not too cold, but just right. With air and sea and land, and maybe life.
And of course the question on everybody's lips, if planets are common throughout the galaxy, what about you and me? What about life?
Well, there's a very large string of factors that go together to arriving at us sitting in this room talking about life or life in other solar systems. The first thing you have to have are lots of stars. We know there are lots of stars, so that's one good thing. The second thing you need to know, are there lots of planets? Then you need to know, are the planets in the right place to have the right temperature? If they have the right temperature, do they have water? And a whole string of things finally leading up to, if there's an imperfect environment for life, does life form there and does it become intelligent? I think we can now make a good case for saying that planets are common around other stars. What will be left to another satellite or to other observations is to push on to those other questions that eventually lead you to the conclusion that, in fact, life is a common thing. And I don't think we know enough yet. That's still in the realm almost of theology, rather than pure scientific fact.
If life has developed somewhere out there, what's it like? Will it have evolved along the same lines as creatures on Earth? Or might it be even weirder? we've got all sorts of weird life on this planet. If there are planets in plenty out there, would you expect to find something like this on them?
I would, yes. I mean, if you're going to get life, it's probably going to follow certain rules, and if you've got plants for harnessing the energy of their sun, whatever it is, then you're going to get big things like elephants and other things like that to eat the plants. So yes, I would expect something a bit like an elephant.
What about these really weird things that science fiction authors tell us exist, like sort of 16-foot-high tripods?
Well, that's a little more doubtful. I think those are really a bit too imaginative. You see, the thing is that I suspect that wherever you're going to get life, it's going to be based on, probably on carbon atoms to store the information and build up the life molecules, and on liquid water. Yeah. And I don't think that's going to enable you to build metallic-looking tripods, you know, that wander around the countryside laying waste to it.
The next intriguing question is how far life on other worlds might have developed. We think of ourselves as pretty advanced creatures, but in astronomical terms, the human race are mere babes. Many of the stars were born long before our sun, and so any inhabitants of their planet will be much more mature. Our idea of a space-age city might seem quaint and primitive to an alien. But if there is advanced life out there, it's not giving itself away. From time to time, radio telescopes search the skies for any hint of signals from alien civilizations. So far, they've drawn a blank.
The irony is that we probably broadcast more about our existence to them than they have to us. Ever since we started transmitting radio and television programs, our radio signals have been leaking away, albeit weakly, into space. And travelling at the speed of light, those very first radio broadcasts made in the 1920s have now reached stars 60 light-years away. And within that radius, that includes literally thousands of stars. And if there really are inhabitants around the very nearest stars, equipped with extremely powerful receivers, they'll be picking up this program too, in 4 years' time.
On one occasion, we deliberately broadcast our existence from the giant Arecibo telescope to the universe at large. The message, pulsed in binary code, showed our number system, the chemicals of life, what we look like, and where we come from. Sounds simple, but it needed an IQ of 200 to decipher it. And some people reckoned we were just asking for trouble. The intelligent aliens who received the message might not be friendly.
Controversial though the Arecibo message was, we've actually been even bolder in advertising our existence. The 2 Voyager space probes, which are destined eventually to leave our solar system, both carry very detailed information about our whereabouts.
They reveal exactly where to find us in the galaxy. There's another plaque on the Pioneer spacecraft, already on its way to the stars. But alien eyes might find this part of the diagram rather difficult to interpret. We've also sent a long-playing record into space, together with a stylus and instructions. These interstellar calling cards won't reach even the nearest stars and their possible inhabitants for 40,000 years. And we naturally expect that they will be falling over themselves to pay us a visit.
And maybe that says it all. We arrogantly assume we'll be recognized, respected, and acknowledged wherever we go. But in truth, where does human life figure in the pecking order of life in the universe? When I look up at the night sky, I can see thousands of stars. Through a telescope, I can see millions more. All of them are suns like our own, and most of them probably have planets. But those planets are no more obvious or important than moths swarming around the lights of a distant city. And yet, many of them may harbour life itself. On some of them, life may be as brief in its period of living and as transitory as a moth itself. But on others, life may have endured and be prospering.